Today we're going to be doing some implicit differentiation. Recently in one of my weekly live streams, I went over a problem where we had to do implicit differentiation to find dy dx, and the equation we were given involved a xy term as well as a trig term. Now, those are two pretty common questions I get, is how to deal with those two types of terms within an implicit differentiation problem. So I thought you might find it helpful to kind of revisit that topic. So I wanted to show you the clip from that live stream where I went over that problem, show you basically the steps of an implicit differentiation problem. I did recently come out with a video where I went in depth into the actual step-by-step process of an implicit differentiation problem. If you do want to check that out, just go click right up there and come back and see this example problem where we go into actually applying those steps. I think that's probably the best way for you to, get a lot more comfortable with implicit differentiation so that you can do it really well when the test comes around, or just so you can get a better understanding of it. Either way, I think this video is going to help, so be sure to stick around to the end of the video so you can get all my tips and tricks of how to solve an implicit differentiation problem. And let's go ahead and jump right into the problem. First thing you want to do is figure out what is your variable, what is your function. Well, looking at this problem, it's telling us that we need to find dy dx, whatever is up at the top of our equation, in this case it's y, that's going to be your function, and whatever is down here on the bottom is going to be your variable. So basically what that tells us is y is a function of x. The reason why that's important is because now what we need to do is take the derivative of both sides of our equation with respect to whatever our variable is. Since our variable is x, because that was on the bottom here, as a result of that, we need to take the derivative of both sides of our equation with respect to x. So taking the derivative of this function with respect to x, basically that just means of both sides. So first of all, we need to find the derivative of x times y. Well, if you have x times y, that's a product of two different functions, basically, where one of your functions is x and one of your functions is y. So we need to use the product rule. Product rule says we're going to first decide what is f and what is g. Doesn't really matter which one you pick for which. So let's just say f is x, g is y. Then you need to find f prime, which is just the derivative of f. The derivative of x with respect to x is just 1, right? Because this term right here only has your variable in it, so pretty much taking the derivative of it is going to behave the way you would expect it to. The derivative of x is 1. Now, for finding the derivative of y, that's where you need to keep in mind that y is an unknown function of x. So to take the derivative of some function of x, if we don't know what the actual function is, we just know the function is called y, the best we can really do is to just say the derivative of y is just the derivative of y with respect to x. Well, how do you say that? That's exactly what dy dx is. So dy dx is going to be the derivative of y, and that's going to be our g prime. Okay, so product rule says we're going to cross multiply these and then add the results together. So x times dy dx plus 1 times y, which is just y. Okay, so that's the derivative of the left side of the equation. Now on the right side of the equation here, again, we're going to have to use product rule because we have x times sine of y. So we have the product of these two functions here. So again, we need to determine what is f, what is g. Let's just say f is x, g is sine of y, and then we need to find f prime and g prime. Derivative of x is 1. Now for the derivative of sine of y, that's where it gets a little bit more tricky. So I said earlier when we were talking about kind of the steps that you would go through, whenever you're taking the derivative of something with your function, typically you're going to have to use chain rule. And the reason for that is you want to think of y as a function of x. So don't think of this as sine of y. Think of it as sine of some unknown function of x, right? If you were taking the derivative of this, you would have to use chain rule because you have this inner function here and then this outer function that it's being plugged into. Sine of f of x is a composite function, so we have to do the chain rule. So chain rule says we're going to do the derivative of the outside function, leave the inside function alone. So we're going to take the derivative of sine, which is cosine, leave the inside function alone. So we're going to take cosine of y, and then we're going to multiply that by the derivative of the inside function, the derivative of y. Well, the derivative of y, just like we found over here, is just dy dx. So we're going to multiply that by dy dx. Product rule says we're going to multiply these across and then add them together. X times cosine y times dy dx plus 1 times sine of y is just sine of y. So we've done our differentiation step. We've taken the derivative of both sides of our equation. Now what we need to do is add and subtract all of our dx or dy dx terms to one side of the equation, and then all of our non-dy dx terms to the other side of the equation. So let's kind of just sort out, first of all, where are our dy dx terms? Where are the non-dy dx terms? So this term right here has a dy dx. This term right here has a dy dx. And then the other terms do not. So this term right here does not have a dy dx, and it is this one. So basically we can move our dy dx terms over to the left, move our non-dy dx terms over to the right. So to do that, if we have a plus y right here, we just need to minus y from both sides. If we have x times cosine y times dy dx, we would just need to minus that over to the other side. So minus that from both sides. And what that's going to do is the y is going to cancel there. The negative xy dy dx is going to cancel with the x cosine y dy dx. So we're just going to be left with, at that point, x times dy dx minus x cosine y dy dx equals a positive sine of y minus y. Okay, so then once we've done that, the next step is to factor out dy dx from your dy dx side of the equation. So both of the terms over on the left side of our equation here have a dy dx. So what we can do is we can factor those out of the left side of our equation. So we're going to be left with x. If we take dy dx out of this first term, the x is going to be left. If we take the dy dx out of this term, we're going to be left with minus x times cosine y. And then obviously we didn't do anything to change the right side of our equation in this step, so we'll just keep that the same. And then now that we only have a single dy dx term, and that's the thing we're trying to solve for, to get that by itself, all we have to do is divide by everything within the brackets here. And of course, whatever we do to one side of the equation, we need to do to the other side as well. So dy dx is going to equal sine of y minus y all over x minus x cosine of y. And that's going to be it for that example. Hey, you made it all the way to the end of the video. Glad to see you found this video helpful. I have made a ton of other implicit differentiation problems. If you do want to check out the videos on those, just go click over there. I'll put them on that side of your screen. And since you did find this video so helpful, just go hit that subscribe button and bell icon down below so you'll be notified when all my new videos come out. And I'm sure there's going to be plenty more that you'll find helpful if you like this one. And we'll keep crushing it all term long in calculus together. Thanks, and see you next time.